In this lesson, we're going to learn synthetic division. Before we learn synthetic division, I want to look at a very basic division example just to review some important terminology. When we're taking 11 divided by 2, we call the 11 the dividend, and the number that you're dividing by, 2 in this case, is called the divisor. Now, if we use basic long division to compute this, we would write our problem like this, and we would say that 2 goes into 11 5 times, and then using the process of long division, we would multiply 5 times 2 to get 10, and then we would subtract, and 11 minus 10 gives us 1. Using the process of long division, the 1 here is called our remainder, and the 5, in other words, the whole number that we get when we divide the dividend by the divisor, is called the quotient. Now, the way that we write our final answer for division problems will be in this format. We write the quotient plus the remainder divided by the divisor. I'm going to copy this down here. So when we compute the division problem, 11 divided by 2, our final answer is the quotient, which was 5, plus the remainder, which we found to be 1, divided by the divisor, which was 2. And if we add 5 plus 1/2, we get our final answer of 5 1/2. So 11 divided by 2 gives us 5 1/2. Now you might have been able to solve this division problem just mentally without going through all these steps. But I wanted to go over these steps to review the important vocabulary words, dividend, divisor, and quotient, and to review how we write our final answer for division problems. Now the rest of our problems will be division problems like this, but they will involve variables. And we're not going to use the process of long division. Instead, we're going to learn synthetic division. So we see here that we have a division problem, but this division problem involves polynomials. A polynomial is just an expression involving variables. So this expression in the numerator is a polynomial, and this expression in the denominator is a polynomial. Let's label our dividend and our divisor. The quantity in the numerator is called the dividend, and the quantity that we're dividing by, or the quantity in the denominator, is called the divisor. Now we're going to use the process of synthetic division to compute all of the problems in this lesson, but please note that we can use synthetic division to divide polynomials only if the divisor is of the form x plus some constant or x minus some constant. If the divisor is not of the form x plus a constant or x minus a constant, then you cannot use synthetic division to compute that division problem. This little image here draws out the steps of synthetic division. You may or may not find this image to be helpful. We're going to go through all of those steps now. So the first step of synthetic division is we're going to draw this little corner here. Then, whatever your constant is in your divisor, you want to write the opposite of that here. So this is a positive 5, so we're going to put a negative 5 here. Next, we're going to list the coefficients of our dividend right here. So we'll list 1 and 3 and -7. Then we're going to draw a line. Now we've set up our synthetic division problem by putting the opposite of this constant in this little corner here, and by listing the coefficients of the dividend right here. Now we're going to run through the steps of synthetic division. First step, we just bring down this number here. So we're bringing down the 1. Then, to continue the problem, we just switch off between multiplying and adding, multiplying and adding, multiplying and adding. We just go back and forth. We start with multiplying, and we multiply this number by this orange number here. 1 times -5 gives us -5, and we put our answer here. Then you need to remember that you always add numbers in the columns. So we're going to add 3 plus -5 to get -2, and we put our answer here. So we multiplied this number times the -5 and put our answer here, and then we added these two numbers to get -2. So we multiplied, then we added, now we go back to multiplying. We multiply this -2 by -5, and we get 10, and we put our answer here. And remember, we always add the numbers in the columns. So we're going to add -7 plus 10 to get 3. And once you get to the end here, you can stop. I always like to put this number in the bottom right corner in red because this last number here represents the remainder. These numbers here represent the coefficients of our quotient. The reason synthetic division is a nice process that's often preferred over long division is because in synthetic division, notice we remove all of the variables and just do calculations with basic numbers. That makes the calculations nice and easy. But since we removed all of the variables, for our final answer, we have to insert the variables back into our quotient. Now, to figure out what variable do we put on this first number in your quotient, you look at your dividend. And you look at the highest exponent in your dividend, which is the x squared. And our exponent in the first number in your quotient should be 1 less than that. So 1 less than x squared would be x to the 1, or x. So the variable that we attach to the 1 is just an x. So I've written this out here for you to see. Again, when you're deciding what variable to attach to the first number in your quotient, you look at your dividend, which is the numerator here, and find the highest exponent in your dividend, which is 2, and the variable that you attach to the first number in your quotient should be 1 less than that. So 1 less than 2 is 1. Then the number next to your remainder is always just a constant, so we'll just bring down the -2 and we won't attach a variable to it. Now we've completed the process of synthetic division. Now we just need to write our answer in the correct form. This is the form that we want to write our answer. Quotient plus remainder divided by the divisor. So I'm going to copy this over here. So for our final answer, we start with the quotient, which in simplest form, we can write the quotient as x minus 2. And then we add the remainder, which was 3, divided by the divisor, which is the denominator in the original problem, x plus 5. So if you take this polynomial and divide it by this polynomial, this is your final answer. To check your work, you could pick any value for x that you want, plug in that value in for x here and compute it, and then plug that same value in for x here and compute it, and you should get the same value because this divided by this is equal to this. Let's take a look at another example. First, let's label our dividend and our divisor. The numerator here is our dividend, and what we're dividing by, or in other words, the denominator, is our divisor. Now be very careful. We can't yet jump into the process of synthetic division because in order to use synthetic division, your numerator must be written with exponents in descending order. Here, these exponents in the numerator are all out of order. We go from w cubed up to w fourth, and then down to w, and then up to w squared. So before we can do synthetic division, we have to first rewrite the dividend with the exponents in descending order, or in other words, written from highest to lowest. So if we look at the dividend here, the highest exponent is w to the 4th. So let's start by writing 3w to the 4th. The next highest exponent would be the w cubed. So next we'll write minus 5w cubed. Then we'll write the w squared term. So we'll write minus 21w squared, then plus 17w, and then our plus 30. And then we're going to divide by our divisor, w minus 3. Now we're going to ignore the original problem. Don't pay attention to it anymore. We're only going to focus on this rewritten problem that has the exponents in the dividend written in descending order. So now to set up synthetic division, we start by drawing this corner here. Then to figure out what number to put in this corner, we look at the constant in your divisor and take the opposite. So this is -3, so the opposite would be +3. Then we're going to list the coefficients of our dividend. Make sure that you list the coefficients of the dividend that's been rewritten with exponents in descending order. Do not write these coefficients that are all out of order. So first we'll list the 3, then the -5, then the -21, then the +17, and last the 30. Now we're going to draw a line here. And now we've set up our synthetic division problem. The first step of synthetic division is to bring down this first number here. So we're going to bring down the 3. Then remember, for the rest of the problem, we just switch off between multiplying, then adding, multiplying, then adding, multiplying, then adding, until we get to the end. First we multiply, and we always multiply the numbers below this line by this orange number. So we'll start by multiplying 3 times 3 to get 9, and we put our answer here. Then remember, we always add the numbers in the columns. If we take -5 plus 9, we get 4. Now that we've added, we go back to multiplying, and we always multiply the numbers below this black line by this orange number here. So we'll take 4 times 3 to get 12, and we put our answer here. Then we always add the numbers in the columns. So if we add -21 plus 12, we get -9. Now we multiply again. We multiply -9 by 3 to get -27, and we put our answer here. And then we always add the numbers in the columns. And if we take 17 plus -27, we get -10. And then we go back to multiplying. We multiply -10 times 3 to get -30, and we put our answer here. And then we add the 30 plus the -30 to get 0. And since we're at the end here, I'm going to put this last number in red, because remember that this last number is always our remainder. These numbers here represent the coefficients of our quotient. And we have to add the variables back on to the coefficients of our quotient. Remember that the exponent that we attach to this first number in your quotient must be 1 less than the highest exponent of the dividend. So let's look at our dividend, and we'll find the highest exponent, which is w to the 4th. So 1 less than that would be w cubed. So let's attach a w cubed to this 3. Then we said on the previous page that the number next to your remainder is always a constant. So we know that this -10 will be a constant. But what do we do with these numbers in between? Well, once we figured out our first variable, w cubed in this case, then our subsequent variables just go down in descending order. So this was w cubed. Our next variable that we attach to the 4 will be w squared. Then the variable that we attach to the -9 will be w. And then we know that the number right next to our remainder is always just a constant with no variable at all. So we've now attached all of the variables onto our quotient, and now we can write our final solution. Our final solution should always be written in this form: quotient plus remainder divided by the divisor. So let's start with the quotient, which we wrote right here: 3w cubed plus 4w squared minus 9w minus 10. Then we add the remainder, which we found was 0, divided by the divisor, which is w minus 3. Now for your final answer, 0 divided by anything is just 0. So this quantity here is just 0. So when your remainder is 0, you don't have to write this second piece here. For our final answer, we can just write 3w cubed plus 4w squared minus 9w minus 10. These last two problems are examples of synthetic division problems that are very, very commonly solved incorrectly. Let's start with number 4. And let's start by labeling our dividend and our divisor. The numerator is the dividend, and the denominator is the divisor. Now we learned on the last page that before you can use synthetic division, you have to check our dividend and make sure that the exponents are in descending order, and they are, but you also have to check for missing terms. If we look in the numerator here, we go from x cubed to x. We're missing an x squared term. If you're missing a term in your numerator, you have to write a 0 in place of that term. So let's rewrite this dividend. We'll start with 5x cubed. We're missing an x squared term, so I'm going to write plus 0x squared. Then we'll write plus 6x and plus 8. And then we'll divide by our divisor, x plus 2. Now that we've put a 0 in for our missing x squared term, now we can go through the synthetic division process. First, we'll draw this little corner here. Then to figure out what to put in this corner, we look at the constant in our divisor and take the opposite. So this is 2. The opposite would be -2. Then we list the coefficients of our dividend, making sure to include this 0 to account for the missing term. If you forget to include this 0, you will get the answer wrong. Then we draw this line here, and now we can go through the synthetic division process. First step, we bring down the 5. Then we multiply. 5 times -2 gives us -10, and we put our answer here. Then we add. 0 plus -10 gives us -10. Then we multiply again. Negative 10 times negative 2 gives us 20, and we put our answer here. And then we add again. 6 plus 20 gives us 26, and then we multiply. 26 times negative 2 gives us negative 52, and then we add. 8 plus negative 52 gives us negative 44. And again, I'm putting this last number in red because this last number is our remainder. Now these numbers here represent the coefficients of our quotient, but we have to attach variables to our quotient. To figure out our first variable, we look at our dividend, and we find the highest exponent in our dividend, which is x cubed. The variable that we attach to the 5 should have an exponent that's 1 less than 3, which would give us x squared. So I'm going to write 5x squared. And from here, the exponents just go in descending order. So we'll bring down the negative 10. And since this was an x squared, the next exponent would just be x to the 1, or x. And then the number next to the remainder is always a constant. So I'm going to bring down the positive 26. Now we have our quotient with the variables attached. Now we can write our final solution. Our final solution will be written in this form. So we start with the quotient, which we have here, 5x squared minus 10x plus 26. And then we're going to add the remainder, which is negative 44, divided by the divisor, which we said was x plus 2. Now we know in math, if you add a negative, that's equivalent to subtraction. So I'm going to change this plus a negative to just subtraction. Let's try one last problem involving missing terms. To start, I've labeled our dividend and our divisor. Now, we want to check our dividend and make sure that the exponents are in descending order, and they are, but we also have to check for missing terms. It looks like we go from x to the 4th to x squared, so we're missing an x cubed. Then we go from x squared to 5, so we're missing an x term. So let's rewrite this dividend, and we'll include zeros for our missing terms. We'll start with x to the 4th. Since we're missing an x cubed term, we'll write plus 0x cubed. Then we'll write minus 64x squared. Then we're missing an x term, so we'll write plus 0x, and then we'll write plus 5. And then we can write this all over x minus 8. Now that we have our exponents listed in descending order, and we've accounted for our missing terms using zeros, now we can go through the synthetic division process. First, we'll draw this corner box, and to figure out what number we put in this corner box, we look at the constant in our divisor, which is negative 8, and we take the opposite. The opposite of negative 8 is positive 8. Then we look at the coefficients of our dividend and list them here, making sure to include the zeros. So I've listed our coefficients here, 1, 0, negative 64, 0, and 5. Again, if you forget these zeros, you'll get the answer wrong. Then we'll draw our line here, and for the first step, we bring down the 1, and then we multiply, then add, multiply, then add, multiply, then add, till we get to the end. Remember, again, you always multiply the numbers below this black line by this orange number here. We'll start by multiplying 1 times 8 to get 8, and we put our answer here. Then remember, you always add the numbers in the columns, so we'll add 0 plus 8 to get 8. Then we multiply. 8 times 8 gives us 64, and we put that here. And then we'll add negative 64 plus 64 to get 0. Then we multiply. 0 times 8 gives us 0, and we put our answer here. And then we add. 0 plus 0 gives us 0. Then we multiply. 0 times 8 gives us 0, and we put our answer here. And then we add. 5 plus 0 gives us 5. And again, I always put this last number in red because this last number is our remainder. Now these numbers represent the coefficients of our quotient, but we have to attach the variables. To figure out our first variable, we look at the highest exponent in our dividend, which is x to the 4th, and we take one less than that, which would be x cubed. So we're going to write this as 1x cubed, and then we just go down in descending order. This isn't positive 8, so I'm going to write plus 8. X squared, the next variable would be x. So since this is a 0, we can just write plus 0x. And then the number next to our remainder is always a constant, so we can write plus 0. Now let's write our final solution. And we will write our final answer in this form. We'll start with the quotient. Now let's make sure to write the quotient in simplest form. 1x cubed can just be written as x cubed plus 8x squared. And since these terms involve zeros, we don't have to write them. So our quotient in simplest form is just x cubed plus 8x squared. Then we add the remainder, which is 5, divided by the divisor, which is x minus 8. So this is our final, fully simplified answer.